Dear students, today we will start different diode configurations. So we are going to start diode configuration. For different So this is the topic for today. We have three basic diode configurations. So first one is the series, second one is the parallel, and third one is the combination of series parallel. So this you can see, this is the series parallel configuration. So we have three types of diode configuration. First one is the series configuration, second one is the parallel combination, and third one is the combination of these two, that is series parallel configuration. Before analyzing different diode configurations, we will see models used for diodes. So we have two types of diode models which are used here. So approximate and ideal diode models. First one is the approximate. In approximate diode model, first you can see this diode characteristic. Here in reverse bias, current is 0. On y-axis you have current, and on x-axis you have diode voltage. So this is like this. Here suppose we are taking silicon diode, then this is the 0.7 volt. And in ideal case, diode characteristic is like this. You have 0 current for reverse bias, and here at 0 positive voltage this starts. So this is the ideal characteristic. We have two parts here, for this part and for this part. So here in this part you can see this diode. We have, this is the diode symbol, and in this part we can use a battery of 0.7 volt, and for this you can use open circuit. So from here to here, this current is 0. Here you can see current is 0. So in approximate model, this one is approximate and second one is the ideal. And in this model, you have a short circuit in forward bias and open circuit in reverse bias. Here this is open. So you can see here current is 0. So these are two diode models which are majorly used for analysis of different diode circuits. So one by one we can see analysis of diode circuits. So this is the first approximate model. In approximate model, from here to here, this current is 0. Means for this reason, this is the equivalent circuit. Means you can represent this part by open circuit. When this is open, current is 0 through the diode. And for this reason, you have a fixed voltage drop of 0.7 volts. So you can replace this diode by a fixed battery of 0.7 volts. Similarly, if we are using ideal diode model, then for this whole reason, negative part, we have open circuit, that is current is 0, and for this reason, we have 0 drop. When drop is 0, you are getting current. So in forward bias, this drop is 0. So these are two models which are majorly used. Now we will discuss one by one series, parallel and series parallel combination of diode. So first of all we will take series combination, series diode circuits. So first one is the series diode configuration. In series diode configuration, here we are taking a very simple circuit. You can take here circuit of this series diode configuration like this. Suppose we are using a battery and a diode with a resistance. This is one of the simplest circuits. Suppose voltage supply is E, you are using a resistance and a diode. So how can we analyze? Analysis. This is one circuit, first one, and when diode is reversed, you can draw like this. This is reverse bias diode. So these are two diodes configurations. So this is figure 1, this is figure 2. What is the difference between these two circuits, these two configurations? In this circuit, this is the forward bias. This is forward bias configuration. And in this is the reverse bias configuration. Why? Because positive terminal of battery is connected to p-type semiconductor. That's why this is forward bias. So when this, for this circuit, diode is on. So you have to see whether diode is on or off. So when diode is forward bias, this is on. Then you can calculate all these voltages. Suppose voltage drop across this diode is VD. Voltage drop across this resistance is PR. And obviously this current, these two currents are same, ID and IR. So how can we analyze this circuit? What are these values? Diode, drop, VR and ID, IR. So obviously this circuit is in series. Then you can write diode current and resistance current, both are same. And when diode is on, what is value of VD? So when diode is on, you can replace this diode, because this is forward bias, you can replace by a short circuit, or you can replace by a battery of 0.7. Okay. So in forward bias, you have a drop of this 0.7 volt. You can, or you can, in terms, you can write VK. VK is called the on voltage. In general, you can represent by a voltage Vk. So what are voltages? Voltage drop across this diode is fixed, that is Vk. And what is this drop? Vr. In series, you can apply KVL. So this drop is equal to this drop plus this drop. So you can write Vr is given by E minus Vk. Because in series, when we apply Kirchhoff's voltage law, all algebraic sum of voltage drop is 0. Then from here you can write Vr equals E minus Vk. And these two currents are same. And for this circuit, so this is for analysis of this first part. In first part, this diode is on. Now come to second part. How can we analyze second part? For this part of the circuit, analysis is, so first think about state of the diode, whether on or off. So diode is in this case off state. Why? Because this is connected to positive terminal. This is the negative part. So diode is off. So that's why you can replace this by open circuit like this. Suppose this is the drop of voltage. This is the battery. This is the resistance. So now you can calculate all voltages. So obviously current is 0. This current is 0. So diode current and resistance current, these two currents are 0 due to this open circuit. And what is value of Vd? This is simply given by this drop, because Vr is 0. There is no drop across this resistance. Suppose here we are taking this resistance, drop across resistance is Vr, then this is 0. So these are two configurations, on state, off state. Obviously, this is in series configuration. Simplest form of the series configuration, in which we are using one battery, diode and resistor. First time we have diode is in on state, and in second time for second circuit diode is in off state. So when diode is on, this is either short circuit or you can replace by a battery of voltage 0.7 for silicon and 0.3 volt for germanium. So these are two configurations. So now you can take few examples. Can take example. So example. First one. Simply we are using a battery, a diode and a resistor. This battery is given, suppose plus minus, E is given 8 volt. Here resistance value is given 2.2 kilo ohm. Okay. And here current is shown. This is the diode current. This is the resistance current. You have to find out Vd, Id, IR, okay, and VR. calculate all these values for this given circuit. So what is the solution for this? So first of all, you will say whether diode is in on state or off. So diode is in on state for given circuit. Why? Because this P type is connected to positive. P type is connected to plus of E. So that's why this diode is in on state. So now you can calculate different voltages. So replace this by equivalent circuit. Suppose this is the drop is here a battery of on state. Suppose this is Dk, and obviously for silicon diode this is 0.7. Then what is Vd? Drop across diode is 0.7 volt. What is these two currents? Id and R. Both currents are equal due to in series. So you can calculate this current by this resistance, because current in this part is, you can calculate here voltage drop VR, and then you can find out the current. So what is value of VR? Drop across this resistance. This drop is this minus this. So this is 8 minus 0.7 divided by this resistance, that is 2.2 kilo ohms. So you can solve this. So this is 7.3 upon 2.2. In you will get the answer in milliamperes. I think this is 3.32 milliamperes. So because these two elements are in series, these two currents are equal. In series, currents are equal. Only drops are different. Here across the diode, this drop is 0.7, and drop across this is the difference of these two. Because in series, total algebraic sum of all voltage drops is equal to 0. Or you can say active drop equals to passive drops. So this is equal to these two drops. So from this you can get voltage drop across VR. So this is one example. So now you can reverse this. Suppose diode is reversed, then what are values? Suppose this is reversed. Okay. Then what are values? Suppose this is the diode. Then repeat this problem for all these values. So now this problem is changed. So now this is second problem. Only you are changing the biasing position of diode. Now negative terminal of diode, that is N type of semiconductor, is connected to positive terminal. So in analysis, how we will analyze? First thing, whether diode is on or off. So in this case, you can say diode is off state. So for this, you can use open circuit model. So using model of, you can see here, this is the diode drop. So using this model, you can calculate first these two currents are 0. These two currents are 0. Because this is open circuit and there is no current through this diode, that's why current through this resistance is also zero, because these two components are in series. So these two currents are zero. When these two currents are zero, then what is this drop? This drop is IR into resistance, current into resistance, simply Ohm's law. So you will get, this is 0 into R, that is 2.2, you can replace kilo ohms, that is 0. So this drop is 0. Then what is next one is VD, this one. So these two currents are 0, this drop is 0. Now come to this drop, VD. What is the drop across this diode? Now you can apply KVL for this. So VD equals, you will get simply this drop E, and this is 8 volt, because there is no drop across this. So this drop is equal to this. So this is the method to analyze series configuration for diodes. So this is all for this lecture. Okay, thank you.